The concept covered in today's video may seem technologically advanced and futuristic to some people. However, artificial intelligence, or AI for short, has actually been around for quite some time. However, before I get into describing the practical applications of AI, I'd just like to define the term. AI, or artificial intelligence, is defined by Oxford as the theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. Now, the first form of artificial intelligence I'd like to tell you about is in the automotive industry. Now, you may be thinking that I'm going to be talking about those new self-driving cars, but you'd be wrong, because today I'm going to be telling you how my 1997 Nissan Pathfinder uses artificial intelligence to run. Now that's bound to turn some heads, because now you're probably wondering, how on earth does such an old car have any form of AI in it, and why is it required for it to run? As it turns out, cars have been using AI ever since about the 1970s. Now, of course, the AI I'm referring to at the moment is called an engine control unit, or ECU for short. An ECU is responsible for taking in information from the car's internal mechanisms, then sending out an output to different parts of the car in order to achieve the desired response. The ECU is responsible for a number of different jobs throughout the car. One of these tasks is receiving information from the accelerator pedal and altering different components within the car's engine to either increase or decrease the speed depending on the pressure applied to the pedal. Other components affected by a car's ECU include the power steering, the cruise control, and the gear shifting in cars fitted with an automatic transmission. Now that I've covered how an ECU can be classified as a form of AI, I'd like to direct your attention to another real-world application of artificial intelligence. Another practical application of artificial intelligence is in manufacturing. The fitting and turning industry falls within that of manufacturing. Fitter and turners use a variety of machines such as mills and lathes to manufacture other parts for machines. Originally, lathes and milling machines were purely mechanical and relied solely on the machine operator's experience and knowledge to manufacture the desired product. However, through the advancements in technology, computer numerical control, or CNC for short, was developed and implemented into these machines in order to make jobs more efficient and easier. A CNC machine uses certain codes that utilize Cartesian coordinates to tell the machine where to go and what to do at that point. Now, although CNC machines in themselves aren't technically classified as artificial intelligence, sometimes programs are used to write the codes for these machines. These programs are currently being improved to allow for AI input. One example of this is in a paper written by Professor Kenneth Priest and Elizia Kapelansky. This paper is titled Automated Part Programming for CNC Milling by Artificial Intelligence Techniques and states that the program solves the problem of achieving the goal state from the initial state by using machining moves and hence writes the part program. What this means is that the program only requires human input on the raw material and the final product, and the computer or AI program will work out the rest. This paper also brings up a very important point about artificial intelligence and what it can mean for the future of mankind. The pair state in their paper that the aim of a program such as this presently seems pretentious and that we wish to replace human decision making by a program. This idea that human decision making will be replaced with artificial intelligence is one of the main arguments against the rapid implementation of these technologies. This is because of the potential unemployment as a result of the replacement by artificial intelligence. Nadimpalli reinforces this point in her article titled Artificial Intelligence, Risks and Benefits, when she states, "By replacing human subjects, it brings in the general problem of putting people out of work." Now, I'm sure that all of you watching will agree that unemployment is never a good thing, whether it be for individuals, families, or economies as a whole. Another downside to the implementation of artificial intelligence is the high costs associated with the purchase, maintenance, and repair of these complex machines. Of course, these costs can be justified if the machine is capable of bringing in more income than it is costing. This brings me to the benefits of mainstream AI implementation. The The first being the potential to increase efficiency in the workplace as a result of AI technology becoming faster in the decision-making process. One example of AI speeds improving is where a team from Tencent Machine Learning partnered with the Hong Kong Baptist University and broke an AI-related world record in regards to the speed in which the AI processed information. Artificial intelligence is also playing an important role in the standardization of products, as also noted by Ms. Nadimpalli. This standardization means that the overall quality of products being manufactured remains consistent. This benefits both the consumer and the business making the product, as the customer is guaranteed the product is to a certain standard, and the business gains the potential for repeat customers or good reputation. That's all the time we have for today's video. I hope it has been informational and provided an insight into the practical applications of AI, as well as outlining potential pros and cons to this ever-expanding technology. Thanks for watching.